Today I'll show you how to find matrix inverse. Let's find the inverse of a matrix A. So here A matrix is given. So that is 1, 2, 3, 0, 1, 4 and 5, 6, 0. It is a 3 by 3 matrix. So first, to find inverse A matrix, we use this formula. A inverse is equal to adj of A, det of A. So that means we need to find two things. One is adjoint matrix adj of A, adj A, and determinant det of A. So if we have that two things, we can easily find out the inverse of a matrix. So first, what is cofactor? So to find a cofactor, we first remove one row and one column. So this row and this column we have to remove, and we will have that 2 by 2 matrix 1, 4, 6, 0. So example here, finding cofactor C11. For position 1, 1, remove first row and first column. So we will get 1, 4, 6, 0. So that is the 2 by 2 matrix, and then we have to find out the determinant. So here determinant we can easily calculate. So that is 1 into 0 minus 4 into 6, that is minus 2, 4. Now we have to check the sign of the cofactor. Sign of the cofactor depend on the position of the matrix. So that is minus 1 to the power I plus j. So here I is 1, j is equal 1. So that will be positive. So now we have to check whether we have to multiply plus 1 or minus 1. So that will be based on the position. So here that A matrix 1, 2, 3, 0, 1, 4, 5, 6, 0. Now sign pattern. So after calculating cofactor, whether cofactor will be positive or negative, so we'll see from this sign pattern. So here first cofactor, that will be positive, second will be minus 1, and third that plus 1. Obviously this is we have to multiply with plus 1 or minus 1. So that actually tells the sign pattern. So first, so that will be multiplied with plus 1, second cofactor, that will be multiplied with minus 1, third one is multiplied with plus 1. Similarly minus, plus, minus, plus, minus, plus. Okay, so this helps us know when to multiply by plus 1 or minus 1. So let's find this first row of the cofactor. So C11, so here that will be multiplied with positive plus 1 and 1, 0, 1, 4, 6, 0. So from that we can get the determinant. So that will be minus 24. Similarly C12 is 20 and C13 minus 5. So here C12, that multiplied with negative 1, that will be actually positive 20. Similarly second row, so we'll get C21, that will be minus 1, 2, 3, 6, 0. So we have to second row and second column, second row. Okay, and then if I do that first column, so 2, 3, 6, 0, that will be 18. Okay, C22, that will be 1, 3 and 5, 0. So that is minus 15. C23 minus 1 multiplied with the determinant, so that is 4. Okay, so here multiplied with positive 1. Then similarly third row we'll get C31 5, C32 minus 4 and C33 1. So now after getting cofactor, so our cofactor matrix will be like that: minus 24, 20, minus 5, 18, minus 15, 4, 5, minus 4 and 1. After getting that cofactor matrix, so adjoint matrix will be just transport of this, means you have to convert the row into column. So here if I do the transpose, so we'll get the adjoint matrix. So that is minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, 1. So that is the adjoint matrix of A. Now we have to calculate the determinant. So here determinant, use first row of the determinant. So 1 into cofactor, 2 into cofactor and 3 into cofactor. Finally we'll get the determinant is 1. So as determinant is 1, so our adjoint matrix is our inverse, because we know that A inverse is nothing but adjugate of A by determinant. So determinant is 1, so whatever adjugate we got, so that will be the inverse matrix. So here inverse matrix is minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, 1. That's it. Thank you.